This. Here we go, you guys. Chapter 5, Summary for Quadratic Equations and Functions. What you'll see here is you have two different quadratics we graphed. One's in standard form, one's in vertex form. And down here we're going to solve different equations using four different methods. Square rooting, factoring, completing the square, and quadratic formula.
Oh, yeah.
So, for standard form, if we were going to graph a quadratic in standard form, that's it right there. You have your ABCs. Negative b over 2a gives you your axis of symmetry. So right here we calculate our axis of symmetry as 1. Dotted line, write down 1. X equals 1. We have a table. X is 1. So 0, negative 1, and 2, 3. All I then do is I plug in 1 to this equation. I plug in 0. I plug in negative 1. And when I calculate it, I get these answers. Now, I don't have to plug these in because what you realize is these answers reflect the same over because this is their symmetry to these. Their symmetry. So this value and this value should be the same. This value and this value should be the same. And you find these again by just plugging the 1, the 0, the negative 1 into this equation. I then plot these coordinates, 3, 2, 2, negative 1, and so forth, as my red dots right here. And I got my parabola. This point right here is my y-intercept. This point right here is called my vertex, 1, negative 2. These little dots right here are my zeros or roots. Yeah, those are very important points to the graph of a quadratic. Anywho, again, for doing standard form, first find your axis of symmetry, create a table, plug in values, plot the values. Now, if it's in vertex form, it's quite a bit easier. Hint the word vertex form, you have HK. So it's negative 1, 2, because it's always the opposite of H. Negative 1, 2 is the vertex. Negative 1, 2. Because this negative 1/2, the A value, is negative, negative values are sad. Positive A values are happy. This is going to go down. If A value is greater than 1, the absolute value of A, meaning ignore the negative for now. If the value of A, ignoring the negative, is greater than 1, it gets narrow. If it's less than 1, it's wide. Since we have negative 1/2, that means it's sad. Ignore the negative. 1/2 is less than 1. So this is a wide graph, so it's a little bit wider than normal. It's right here. And then the quick way of graphing this is because of this negative 1/2, if I go one step over to the both right and to the left, the 1/2, since it's negative, means I'm going to go down 1/2. And that gives me 2 quick points, and I can make a quick sketch. Let's say the number in front was 3. I would go to the right and left 1 and go up 3. And then I have a quick little sketch. Whatever your A value is tells you how far up or down you're going one step to the right and to the left. That's the quickest way of graphing. This is very quick for graphing if you know what you're doing. Especially if you look at this data, you can really quickly get a feel for what it looks like. So, standard form, vertex form, graphing of quadratics. Now when we go to solving quadratics. Solving tends to usually find the zeros of the quadratic, where it crosses the x-axis. Anywho, you can solve by square rooting. So here's a problem. If I want to solve by square rooting, you got to get it all by itself to get x squared equals 20. Then you square root both sides. And 20 breaks down to 2 and 5, square root 5. And don't forget plus or minus. A lot of times people forget plus or minus. They forget the minus right there, like I did. But it could be two answers, a positive or a negative, 2 square root 5. For solve by factoring, what you have to do is you have to get everything over to the left. Basically everything equal to 0. Once you get everything equal to 0, you factor. See right here my factoring technique. And then once you factor, you set each factor equal to 0, called zero product property. And you get your answers. Factoring is one of the easier methods. Actually, this is probably the easiest, then this. If you get good at this, this can be very useful. Completing the square, what you do is you add the 2 over, you get blanks right here. And you're going to add something, so you get a perfect square over here. Where the 16 came from is I took half of b and squared it. I then add that to both sides, because we're allowed to do that in algebra. I then factored this, got x plus 4, which becomes x plus 4 squared. These two add up to 22. When I square root both sides, don't forget plus or minus, and then minus the 4 over. There's your answer, which you can use a calculator to calculate the actual number. So you got these three, and then quadratic formula is very common, always works, nice little method, but people tend to mess up inside of all this simplifying. Now, what we got here is, right here we got the negative b, there's the formula. We got a, b, and c. So when I plug it all in here, it looks like I made a mistake. That should actually be a positive one, so ignore that negative. It's a positive one. You can't even see it, but that should be a positive one. And the opposite, anyways, you do all the math inside, you get a positive 24, which is 25. The square root of 25 is 5. And then you do negative 1 plus 5 over 4 and negative 1 minus 5 over 4, and you get your two answers. Quadratic formula doesn't always break down to nice numbers like this. A lot of times it breaks down and it looks something like this. But those are your 4 methods of solving. These are your 2 graphs for quadratics. Hopefully that helps.